मैंने थोड़ा सा insist किया कि I want to talk to the students, I want to tell them about interesting stuff that's happening, because I think a lot of times we work in our own little boxes. आप लोग क्लास पढ़ रहे हैं, टीचर क्लास पढ़ा रहा है, आपका और टीचर का इंटरेक्शन फंडामेंटली एक मैच है कि किसने ए लेके दिखाना है और कैसे उसको ए लेने से रोकना है. So the teacher is putting up obstacles in your way. At least that's how the students think about it, and students are somehow, so there's some kind of a cat and mouse game that's going on for grades. I'm part of 10xEngineers. We co-founded that company. That's not a game that I like to play, right? In fact, the one reason why I'm not in academia is because I don't like playing that game. So I do teach a course, a graduate course, every year on the specific areas जिसमें हमारी company काम करती है. But the purpose there is to seed strong master's programs in that area in Pakistan, right? So this particular lecture, coming to this class is usually to learn from you. What are you thinking about? What are your questions? What do you want to see as your future 4 years from now when you graduate? So आज 1 मिनट के लिए बाकी सब चीज़ें सस्पेंड करें, वो कैट एंड माउस गेम को तो डेफिनेटली साइड पे कर दें, एंड जस्ट आस्क योरसेल्फ दिस क्वेश्चन कि आज से 4 साल बाद मैं जो भी कर लूँ, माँ बाप ने कहना है कि यहाँ से तो बाहर निकलो, बहुत फीस दे दी. I will be working and try to, so we are going to give you a small window, बिल्कुल जैसे वो peephole होता है उससे, we are going to give you a small window on one type of work that happens. ठीक? So just look through that peephole, try to imagine the bigger picture that's out there and ask us all the questions. ठीक है? आज बस हम ये करेंगे. So that's how we are going to do it. ठीक है जी? मज़ा आएगा? सही? I don't know इसके बाद assignments, so there's stuff that we want you to do after this, but more importantly, I think at least for this next 1.5 hours, let's pretend that you've graduated and you're asking us question कि ये आप लोग क्या करते हैं, right? So one of the questions I get asked very often, that's the second most popular question I get asked, is 10x करती क्या है? पता नहीं, ये मुझे नहीं समझ आया कि how did it become a female, but okay, fair enough. 10x करती क्या है is a question that I get asked a lot. So today we're going to sort of zoom out and not just focus on 10x but focus on the industry, and you're going to ask us questions कि क्या है. ठीक है जी? How many of you are thinking about choosing computer science? शर्माना नहीं है, शर्माने की कोई बात नहीं है. आप आंखें बंद कर लें मुझसे भाई. डबल ई वाले सारे आंखें बंद कर लें. ठीक. So 1, 2, I saw another hand, 3, 4. Decided? Undecided? You will not take computer science. Oh, you have already opted for computer science. Okay. And about you? Not decided yet. Okay. Fair enough. So the reason why I understand that's what most of the students are thinking about these days, right? And I have no problem with that. I can see why. The purpose though is to give you a big, जैसे मैंने कहा कि there's a world out there that you haven't seen. And we want to show you that world. ठीक है? So suspend your bias कि मैंने तो computer science करना है, मैं इसको क्यों देखूं? And just indulge with us for a hour and a half in trying to figure out कि ये है क्या चीज़ जो हम करना चाह रहे हैं. ठीक है? मज़ा आएगा. So I have an electrical engineering background. I have a computer engineering master's and PhD. I have some respect for computer science people, which means I have respect for some people within computer science. But I think it'll be an interesting conversation. So if you look at this picture, this is an actual picture of a physical chip. जब उसके ऊपर से आपने अगर कभी chip देखी हो तो वो काले से रंग की होती है, right? That's really the plastic package जिसके अंदर actual silicon की die है, right? It's called a die. If you take off the plastic का ढक्कन, तो inside it is a small piece of silicon. Typically, if you look at the processor that's powering your own phone, it would be the size of a nail, about 1 centimeter squared. So that small piece of silicon is what's doing all the computation. वो आपका screen भी चला रहा है, camera भी चला रहा है, जो आप game खेल रहे हैं वो भी चला रहा है. अगर आपने कुछ render करना है तो वो render भी कर रहा है, वो videos भी play कर रहा है, वो obviously cell tower से communicate भी कर रहा है, data भी भेज रहा है, voice भी भेज रहा है. All of that functionality is put in that chip in different blocks. ठीक? So this is a picture of that chip zoomed in. See? इसके डिफरेंट ब्लॉक्स हैं. सो दिस इज द ब्लॉक विच इज द इमेज सिग्नल प्रोसेसर जिसकी वक्तावर बात करी थी. सही. तो वो सारी कंप्यूटेशन जिसका हमने जिक्र किया कि फ्रॉम ट्राइंग टू कैलकुलेट द ग्रीन वैल्यू एट एवरी पिक्सल लोकेशन, the red value, the blue value, then trying to create an image that does not have noise, क्योंकि light ठीक नहीं थी, light correct. All of that functionality goes in this. See? So, but that's not the whole chip. And we are talking about the chip that is in every one of you's pocket, right? Then there are other pieces that perform other functions जो वो chip करती है. See? So for example, there is a part that does connectivity. Wi-Fi पे हम connect करते हैं अपना phone. हम अपना फ़ोन सेल टावर के साथ कनेक्ट करते हैं, ब्लूटूथ के साथ कनेक्ट करते हैं. ऑल ऑफ दैट कनेक्टिविटी, देयर इज हार्डवेयर दैट डज दैट फंक्शन. सो दैट्स द कनेक्टिविटी पार्ट. सिमिलरली द जीपीयू जो ग्राफिक्स रेंडर कर रहा है, व्हेन यू आर ट्राइंग टू प्ले अ वीडियो गेम ऑन योर फोन, व्हेन यू आर ट्राइंग टू प्ले अ मोबाइल गेम ऑन अ फोन, दैट इन द सीन जो आप देख रहे हैं वो कहीं पे वीडियो सेव तो नहीं हुई हुई, राइट? इट्स नॉट लाइक इट्स प्लेइंग अ वीडियो, इट्स एक्चुअली क्रिएटिंग दैट वीडियो ऑन द फ्लाई. ठीक. The hardware that does that is called a graphic processing unit, and that's that part. So net, there's a lot of interesting pieces of hardware that have to be designed. Each one of them has a very specific functionality, and it's very good at doing that functionality. Can somebody try to figure out, okay, why do we need these different pieces of hardware to do this? Why can't we just have a general purpose processor, a simple processor, and just write software that does all of this? ऑपरेशन तो ज़्यादा प्रोसेसर लगा लेते हैं, 20 लगा लेते हैं, ये सारे छोटे छोटे प्रोसेसर लगे. सो ऑन द टॉप राइट इज द सीपीयू, करेक्ट? दैट्स वेयर योर, हम जो फ़ोन खरीदने जाते हैं हम कहते हैं जी 4 कोर वाला फ़ोन. ओ यार तेरा तो थका हुआ फ़ोन है, 4 कोर वाला, मेरा 8 कोर वाला फ़ोन है ना? सो दैट्स वेयर ऑल द सीपीयूज आर. बट सी हाउ स्मॉल ऑफ अ पोर्शन ऑफ द होल चिप इज द सीपीयू पार्ट. सो टिपिकली इट्स लेस देन 1/4 ऑफ द चिप. तो हम ऐसा करें कि अगर सारे की सारी चिप में बस सीपीयू ही लगा दें और सारा कुछ सॉफ्टवेयर में करने लग जाएं, तो हम ऐसा क्यों नहीं करते? एनी गेस? ये नहीं बेटा? मरियम जी, मरियम. There must be an upper limit to the processing speed. That's true. कि yes, we are looking for, when we are trying to buy a phone, we are looking for the best there is. है ना? उसकी ग्राफिक्स ज़बरदस्त होनी चाहिए, कैमरा तो अंत होना चाहिए, तभी मज़ा आएगा, राइट? एंड देर आर लिमिट्स टू व्हाट द सीपीयू कैन डू. बट हियर्स एन इंटरेस्टिंग पार्ट. व्हाट एल्स डू वी वांट इन आवर फोन? सारा दिन बैटरी चलनी चाहिए, है ना? दिन में चार्ज करने की ज़रूरत नहीं होनी चाहिए. सो व्हाट वी केयर अबाउट इज़ कि ये सारी जो कंप्यूटेशन परफॉर्म करनी है मेरे फ़ोन ने, वो करे लेकिन मिनिमम पावर के साथ करे, है ना? Because if it's doing all of that, but really the phone drains out in an hour, nobody's going to buy that phone. है ना? So the trade-off, the balance that we have to strike is that our hardware should perform the computation efficiently in terms of time, but also in terms of power. सही? And specialized hardwares are more efficient. मैंने एक hardware डिज़ाइन किया जो सिर्फ 2 numbers को add करता है, versus एक hardware जो ऐड भी कर सकता है, सब्ट्रैक्ट भी कर सकता है, मल्टीप्लाई भी कर सकता है, डिवाइड भी कर सकता है. दैट्स अ मोर कॉम्प्लेक्स पीस ऑफ हार्डवेयर, करेक्ट? जस्ट विदाउट अंडरस्टैंडिंग हार्डवेयर वन कैन सी कि हाँ, अगर ज़्यादा फ्लेक्सिबल होगा तो ज़्यादा कॉम्प्लेक्स होगा. उस कॉम्प्लेक्स पीस ऑफ हार्डवेयर से सिर्फ अगर मैंने एडिशन ही करवानी है बार बार, तो आई एम गोइंग टू वेस्ट अ लॉट मोर पावर, बिकॉज दैट्स राइट. देयरफॉर वी डिज़ाइन स्पेशलाइज्ड सर्किट्स, स्पेशलाइज्ड पीसेस ऑफ हार्डवेयर, बिकॉज दे आर मोर पावर एफिशिएंट. ठीक? So why do I talk so much about, why am I showing this picture? Because this is one of the chips that I worked on. So for about 8 years I was at Qualcomm. We were doing जो भी Snapdragon, literally the word Snapdragon was invented by our marketing team while I was there. उससे पहले उसे Snapdragon नहीं कहते थे. So I worked on about 8 generations of that. So the last phone that I worked on was, I believe, S10 was the last chip. तो उसके बाद का फ़ोन अगर आपके पास है तो उसमें मेरा कोई कसूर नहीं है. ठीक है? अगर उसकी बैटरी जल्दी ख़राब हो जाती है, कैमरा अच्छा काम नहीं कर रहा, तो मेरा कोई लेना देना नहीं है. बट द रीज़न वाई आई ब्रिंग दैट अप इज़ बिकॉज we're going to talk about sort of three things. We're going to talk about chip design, the art of chip design. Some of it is intuition. Some of it is based on how things will happen, imagining the future and sort of projecting. Some of it is hard science, which is what obviously our engineers study, right? And then some of it is the business. One has to understand all three in order to actually do the work. Okay? So at 10x Engineers, we don't design our own chips. You will never buy a chip that says, ye ji 10x Engineer ki bani hui hai. No Snapdragon will be made by 10x Engineers. We work with companies that are designing their own chips. Okay? So in some sense, we are the partners to the companies that whose chips you can buy in the market. Okay? Why do they work with us? Because we have specialized skills in certain areas that they don't. सही? तो कहेंगे यार ये वाला हमने काम करना है, इसके लिए for example we are making a chip that requires an image signal processor. You have a team that can build image signal processors. हाँ हमारे पास भी बंदे हैं, but you have a larger team, a more specialized team. Why don't we partner together? आप image signal processor में हमें help करें, chip हम बनाते हैं. ठीक? That's really in simple terms the business that we engage in. ठीक? Okay. Now how I want to give you a sense of the business. ठीक? So when Qualcomm makes its premier tier chip that goes in the flagship Samsung Galaxy phone, so for example, the S22 is the latest, I think? 23 is the latest, okay. So 23 is the S23, right? So the S23, you will be able to buy an S23 with a Snapdragon 8 whatever, or with an Exynos chip. The Exynos chips are made by Samsung itself, designed by Samsung. The Snapdragon chips are designed by Qualcomm. Okay? So typically the cost of designing that one chip is about $1 billion. ठीक? तो अगली जब IMF की हमने ट्रांच ली, तो मेरे ख्याल है उससे एक चिप बनाते हैं. So you can imagine the amount of money it costs to make that. ठीक? But why does Qualcomm do that? Why would you do that, right? And how much money can you make if you do that? So take that premium tier chip. It used to sell back in the day. Now it's more expensive. It used to sell for about $45. See? So आपका premium tier phone, this is when the premium tier phone was about $500. Now the premium tier phones are $800, $900, but this was around that time. So about 10% of the cost of the phone was just the main SoC that was powering it. ठीक? $45 का वो है, 1 बिलियन खर्च कर दिए हैं, काफी सारे बेचने पड़ेंगे to make money, है ना? So really the chip or some derivatives of that chip have to sell in hundreds of millions of parts in order for there to be a profit on these things. So if you do the rough math, that's about 200 million. ठीक? That's how you get 1 to 13 in profit from that device. Typically, this is not how it works out. There are 200 million premium tier Samsung Galaxy phones नहीं बिकते. और अगर उसमें आप LG and बाकी भी शामिल कर लें, तो भी वो the premium tier Android market is not that big. And then share gets taken away because Samsung does its own Exynos chip, and Huawei does its own chip, and sometimes Oppo and Vivo are using MediaTek chip. So there are other companies that are competing for that market. See? So what ends up happening is that you design this premium tier chip, you spend that $1 billion in designing that premium tier chip, you make very little profit on that premium tier chip, but then you create the derivatives of that. The Samsung A53 and the A51 tier chips, जो कि उसी chip का derivative है, उसमें से functionality कुछ बंद कर दी गई, कुछ remove कर दी गई, and now those sell in hundreds of millions.
Cost 45 है
जो premium tier की है. So like I said, this data is a little bit old, purposely. But yeah, the premium tier is not very profitable.
Derivative होगा, उसमें कुछ चीजें वो
बंद कर देंगे और कॉस्ट भी कम कर देंगे. या क्योंकि वो प्रीमियम टियर फोन नहीं है, वो $500 का नहीं बिकेगा, वो 300 का बिकेगा, तो द पार्ट विल बी लाइक $25-20.
मैन्युफैक्चरिंग कॉस्ट सेम रहेगी
नहीं. सो मजे की बात ये है कि अगर आप इस चिप की तस्वीर देखें, राइट, सो दिस हैज फॉर एग्जांपल अ वेरी हाई एंड ISP. तो जो नेक्स्ट ईयर का फोन होगा उसमें ISP में वो सारी फंक्शनैलिटी नहीं होगी, सो दिस विल एक्चुअली फिजिकली बी लोअर. So अगर आप कॉस्ट देखें, the interesting thing in your question is, देखिए कॉस्ट दो तरह से आ रही है. एक आ रही है कि चिप को एक्चुअली मैन्युफैक्चर करने की कितनी कॉस्ट है. यानी मैं चिप डिज़ाइन करता हूँ, मैं चिप बनाने वाली फैक्ट्री को देता हूँ, वो चिप बनाने वाली फैक्ट्री उसको मैन्युफैक्चर करती है और मुझे हर चिप की एक सर्टेन कॉस्ट चार्ज करती है कि ये जी $5 की आपको चिप मिल गई, ठीक। एक है उसको डिज़ाइन करने की कॉस्ट, जो मेरे अपने इंजीनियर्स हैं जो काम कर रहे हैं उनको मैं तनख्वाहें दे रहा हूँ, टूल्स मैं इस्तेमाल कर रहा हूँ, सॉफ्टवेयर हार्डवेयर इस्तेमाल कर रहा हूँ टू बिल्ड दैट, देयर इज अ कॉस्ट ऑफ डूइंग दैट, करेक्ट। there's what is called the non-recurrent engineering cost of building the chip, and then there is the unit cost of each chip, correct. So in the premium tier I pay a huge cost in the non-recurrent engineering part, जो डिज़ाइन करने का खर्चा है वो काफ़ी ज़्यादा है, उसके बाद जो ईच चिप है वो भी कॉस्ट करती है काफ़ी सारे पैसे, बिकॉज वो बड़ी सारी चिप है, कॉम्प्लेक्स चिप है। डेरिवेटिव में ये कॉस्ट बहुत कम हो गई, आई डोंट हैव टू इन्वेंट न्यू थिंग्स, आई एम टेकिंग व्हाट हैज़ ऑलरेडी बीन डिजाइन्ड एंड इन्वेंटेड एंड आई एम सिंपली स्टैंपिंग आउट मोर ऑफ दोज, सही। सो वो कॉस्ट कम हो गई मेरी, एंड नाउ आई कैन मेक मोर प्रॉफिट ऑन दोज डेरिवेटिव प्रोडक्ट्स, ठीक। सो मज़े की बात यह है कि अगर आप सारे, आप में से कौन प्रीमियम टियर फ़ोन हमेशा ख़रीदता है, जो टॉप ऑफ द लाइन फ़ोन है? शर्माए नहीं, दोस्तों को पता होता है वैसे ही। सो अगर आप सारे सिर्फ प्रीमियम टियर फ़ोन खरीदने लग जाएं तो कॉलकॉम बंद हो जाएगी, ठीक। सो जो भी सेकंड टियर फ़ोन खरीद रहा है उसको शाबाश दें, उसकी वजह से प्रीमियम टियर चिप जो है उस को बनाने के पैसे होते हैं। Does that make sense? So this is sort of the paradigm of that. Okay. So that's really what happens. Now, if you think about a company like Apple, do you know how many phones they sell per what? More than that. Apple sells about 75 million every quarter. 7.5 करोड़ फोन हर 3 महीने में बेचते हैं वो, सही। नाउ इमेजिन फॉर अ मोमेंट कि आपने 7.5 करोड़ कुर्सियां बनानी हो हर 3 महीने में, मुश्किल काम है, बहुत सारे बंदे लगेंगे, है ना। लेकिन कुर्सी की मैन्युफैक्चरिंग इतना मुश्किल काम नहीं है। When it comes to making these chips, the chip is the size of this fingernail, 1 centimeter square. The smallest wire that I draw on it is how wide. एक तार है, मैंने उस सिलिकॉन के ऊपर तार बिछाई है, right? Do you know how thick that wire is? Nanometer. एक नैनोमीटर कितना होता है? 10 to the power minus 9. सही? It's usually in a few nanometers. 10 nanometers, 8 nanometers, 7 nanometer. That level of width. 7 nanometer में कितने एटम, या 1 nanometer में कितने एटम पूरे आते हैं? Generally we think of angstroms, right? एक एटम अगर एक एंगस्ट्रॉम का हो तो 1 नैनोमीटर में कितने हुए? 10, ठीक। तो 10 नैनोमीटर अगर उसकी विड्थ है तो 100 हो गए। सो आई हैव टू ड्रॉ अ वायर जिसकी विड्थ इज 10 एटम, ठीक। एंड आई हैव टू ड्रॉ अ ट्रांजिस्टर विच इज अबाउट 20 नैनोमीटर इन डिमेंशन, ठीक। ऑन अ सिंगल चिप, on the latest M1 chip, you have more than 3 billion transistors. 3 अरब से ज़्यादा transistors, जो कि इतने छोटे छोटे। हर एक ट्रांजिस्टर ठीक चलना पड़ेगा वरना चिप नहीं चलेगी, सही। Making these chips is arguably the most complex thing that human beings do. Making one chip. And now imagine trying to make 75 million of them every 3 months, and all of them have to work. This is arguably one of the most difficult things that human beings have created. हमने completely खुद से बनाया है, बिल्कुल कोक की तरह, right? कि we came up with the formula, we came up with the machines that do it. Every year we are coming up with better and better machines to pack more and more of these transistors in the same 1 centimeter square of area. When we pack all of them and we deliver power to them and we try to do computation from them, they get very hot. We have to then extract energy out of them. We created new materials that are there to pack these things and take heat out of those things and cool those things so that when we hold the phone is not too hot. See? So I'm going to show you a short video from from Intel. I want to show you a quick glimpse of what it involves to build these chips.
The world is producing data at an unprecedented rate, faster than our ability to analyze and understand it. To move, store, and compute all of this data requires incredible processing power. From the blazing speeds of our devices to blazing trails within AI, Intel builds chips that are at the heart of nearly everything. Within every Intel chip manufacturing facility across the globe, innovators are pushing the limits of science and literally rearranging atoms to create groundbreaking technology. This strong silicon foundation is what gives each Intel chip limitless potential. At the heart of all modern electronics, the transistor is a tiny switch 10,000 times smaller than a human hair that controls the flow of electrons through a circuit. To build a processor, billions of transistors are packed into an area no larger than a fingernail. It's one of mankind's most complex feats and a remarkable achievement that Intel has essentially doubled transistor density in every new generation of processors. The process begins when silicon-rich sand is melted and cooled, forming a solid, which is then sliced into wafers. Once inside an Intel fab, the raw wafers begin their long journey through an incredibly complex process. They're loaded into front-opening unified pods, or FOUPs, which travel hundreds of miles along Intel's automated superhighway, going from tool to tool, as processors are painstakingly built up on each wafer. The wafer first goes through a series of important steps, such as photolithography, ion implantation, and etching, that prepare it for the critical transistor formation process. Intel was the first to manufacture three-dimensional transistors called FinFETs. FinFET construction requires first building a channel in the form of a fin. Intel has devised several innovations to overcome fundamental barriers to continued transistor scaling. One such innovation is a breakthrough fabrication method called gate last. It involves building, then removing a temporary gate in order to precisely place the dielectric material and metal gate. This allows for the gate to wrap around the fin and control the flow of electrons through the channel. Another invention moves the transistor contact directly over the active gate. To accomplish this, the gate material is recessed and then filled with insulating dielectric material to prevent the creation of a short circuit. Next, the dielectric near the gate is etched, filled with metal, recessed, and capped to allow a novel self-aligning process that enables the high-density contact geometries. Now, the dielectrics are etched selectively to expose only the desired part to connect to the first metal lines. This is done through an innovative via etch and deposition scheme, allowing contact over active gate to happen. Finally, dozens of layers of metal interconnect lines are added to complete the circuit. After more than 1,000 of these complex steps, the wafers are finally prepared for singulation and packaging. Innovative processor packaging has become a critical feature of advanced computing architecture. 2D and 3D packaging technologies are enabling new device form factors and additional boosts in performance and energy efficiency. Testing of the final product ensures that every chip exceeds our performance and quality standards. In addition to adding more performance and features with each new processor generation, Intel's integrated design and manufacturing capabilities have enabled humanity to innovate game-changing technologies that impact nearly every facet of modern life. Intel keeps powering the world. At the same time, we're powered by you, the makers, the dreamers, the doers, the people who share in our history of making the world smarter, faster, and more connected.
So you saw that कि एक ट्रांजिस्टर बनाने के लिए कितना स्यापा करना पड़ता है, and we have to pack 60,000 of them on the width of a human hair. तो अपना बाल काटें, उसका टॉप देखें और imagine 60,000 of them going through each one of those steps, done several billion times over on a single chip, times several billion times done every day. That's the complexity of this process that we're talking about. So therefore, this requires a very high level of skill in designing, in breaking down the process. So Saad, when he spoke to you, he talked about abstractions, right? Now you can imagine why abstractions are necessary. Because someone who's creating, and a Bakhtavar who's creating that algorithm, which will eventually convert into hardware, cannot think about the transistor, cannot think how the chemistry will be done to make that transistor. She has to think about what is the noise, how do I get the right white color in this image, and that's the abstraction level that she has to work on. Then somebody takes that algorithm, that computation that has to be performed at each image, converts them into AND gates, OR gates, NOR gates, so that this can be manufactured. And then somebody else takes that and comes up with a drawing that says कि ये वाला ट्रांजिस्टर इस ट्रांजिस्टर से कनेक्ट होगा, इस वायर के थ्रू कनेक्ट होगा, वो वायर यूं जाएगी और दूसरी वायर यूं जाएगी ताकि ये आपस में शॉर्ट ना हो जाएं. And then somebody takes that and converts that into what we saw in that video of how it's actually manufactured. So abstraction at each level is important, and each level requires expertise that are extremely specialized in that domain. And they're not easy to capture, they're not easy to develop, they take time, they take energy, they take sort of a lot of interesting. So that's where I think from a learning point of view, from sort of a, एक होता है ना कि जो काम मैं कर रहा हूँ ना उसमें कोई sense of wonder भी होना चाहिए, right? That's where it comes in. कि how an idea eventually gets in to a real design and in the hands of somebody, so is something that creates that sense of wonder in what we do. So quickly let's sort of talk about a little bit of the history of this thing. आपने उस presentation में देखा, they talked about doubling the number of transistors. So this industry of making chips since the 1970s has been following what was called Moore's law. Gordon Moore was one of the founders of Intel, one of the earliest inventors of transistors and how transistors were made and chips were made. उसने ट्रेंड्स देखे कुछ साल के पिछले टाइम से पिछले 5 साल के ट्रेंड्स देखे और उसने कहा कि मुझे लगता है कि हम एज एन इंडस्ट्री हर साल नंबर ऑफ ट्रांजिस्टर्स इन अ चिप को डबल कर देंगे एट द सेम कॉस्ट. यानी हम इनोवेट करते रहेंगे, नई नई टेक्निक्स दरियाफ्त करते रहेंगे. पिछले 5 साल के ट्रेंड से तो ऐसे ही लग रहा है, ठीक. So he made that prediction कि every 2 years we as an industry, the semiconductor industry that makes these chips, will be able to put double the number of transistors on the same chip at the same cost. That was what Moore's basic observation was. It was an observation कि मेरा ख्याल है कि हम ऐसे कर लेंगे. Really the industry took that as a challenge कि हमने ये करना है, right? And they started doing that. So since the 1970s that has been happening. जो पहला ट्रांजिस्टर था, अगर आपने उसकी वो तस्वीरें देखी हों, वो बड़ा सारा हैंगर की तरह का ट्रांजिस्टर था, राइट. छोटा करते गए आप अपनी लैब में चिप्स इस्तेमाल करते होंगे, उन इतनी बड़ी सारी वो चिप होगी, उस चिप के अंदर मे बी 200 ट्रांजिस्टर्स हों, करेक्ट. एंड दैट्स अ वेरी ओल्ड प्रोसेस, मे बी 1980s के वक्त की वो सॉर्ट ऑफ इजाद है. वहाँ से लेके अगले 40 साल में वी हैव स्टार्टेड टू पैक मोर एंड मोर एंड मोर एंड मोर until to the point that we've reached here. Now we have gotten to a point that a single transistor has just a few atoms in it, and we are running against an actual physical wall. कि इससे ज़्यादा छोटा कैसे करें भाई, एक एटम से छोटा कैसे करेंगे ट्रांजिस्टर को, राइट. मतलब कोई एटम तो चाहिए ना कुछ बनाने के लिए, एक फिजिकल चीज़ है, एक स्विच है, उसने ऑन होना है, ऑफ होना है, उसके लिए कम से कम एक एटम तो दे दो मुझे, राइट. एक एटम से कम में तो नहीं कर सकेंगे. So we're getting to a point where trying to pack more transistors onto the same chip is running out, which means that we have to make more efficient use of those transistors, है ना? Which is the next abstraction layer above. यानी एक वो लोग हैं जो ज़्यादा से ज़्यादा ट्रांजिस्टर पैक करने की कोशिश कर रहे हैं, राइट, मैन्युफैक्चरिंग वाले लोग। फिर एक वो लोग हैं वो कह रहे हैं कि हमें लगता है कि अब तुम मजीद नहीं कर सकोगे हमारे साथ ये। पहले तो हमारा चैलेंज ये था कि तुम हर साल हमें ज़्यादा ट्रांजिस्टर्स दे देते थे और हमने उनको इस्तेमाल करके चिप्स को बेहतर बनाना है। अब हमें लग रहा है कि तुम हमें मजीद ट्रांजिस्टर नहीं दे पाओगे, तो अब हमें ये करना है कि जो ऑलरेडी ट्रांजिस्टर्स अवेलेबल हैं उनके यूज़ को बेहतर किया जाए, ताकि यूज़र को ऐसे लगे कि जैसे मेरा फ़ोन बेहतर हो गया लास्ट टाइम से, मेरा लैपटॉप बेहतर हो गया लास्ट टाइम से, उनको ज़्यादा एफिशिएंटली इस्तेमाल किया जाए। दैट्स व्हाट कंप्यूटर आर्किटेक्चर इज़ ऑल अबाउट। यू विल टेक अ कोर्स इन कंप्यूटर आर्किटेक्चर, दैट्स व्हाट आर्किटेक्ट्स डू। दे ट्राई टू फिगर आउट what are the better techniques to build these processors, build these chips, so that we can get more work done from the same number of transistors. ठीक? That's what that level of abstraction does. So this sort of graph ये आपने उस picture में भी देखा था, on the x-axis is time, years, on the y-axis is number of transistors, and that's on log scale. See? So it's an exponential curve. Okay जी. So I'll skip sort of some of these things, but where are we headed? So where we headed is, one part is this, okay, number of transistors per chip are going to try and eventually they will not be able to pack more and more. उसकी एक तो ये physical limit मैंने आपको कहा, दूसरी limit है power की, कि every transistor needs some energy in order for it to turn on and off, and as you pack more and more, the power density goes up. See? So how are you able to deliver that power, and are you able to extract the heat that it produces out of that? That's another limit. So what are we going to do? Maybe we'll change the materials. Maybe we won't make them out of silicon. Maybe we'll make them out of something else. Maybe we'll continue to innovate in the architecture, how we use those transistors on a chip to do functionality. Maybe we'll go towards computers for different materials or different ways of manufacturing chips for different tasks. So for example, quantum computers can be very efficient in certain types of algorithms. Certain types of functions के लिए वो बड़े efficient है. So maybe we'll develop quantum computers for those functions, and we'll have other types. So maybe the silicon chips will continue to work for other kind of chips. Maybe we'll have some biology-based devices that will actually do computations in different ways. There's a very interesting talk. I encourage you all to watch that. It's called the Golden Era of Computer. It's about 5 years old. Turing Award, I don't know if you know, it's sort of the Nobel Prize in computation, right? Because Nobel Prizes are only for physical sciences. In computing, the equivalent is the Turing Award. So this is a lecture by 2 Turing Award winners. They are architects, they design processors, and they've been doing that, and that's their lecture. And they talk about what's the future of hardware design. So it's an interesting high level sort of future. Next 20 years, how will things evolve? And frankly, what's interesting about it is that their predictions were almost exactly right. The only difference is that it probably happened faster than they were predicting. They were saying this will happen in the next 20 years. It really happened in the next 5 years, and that's where we are. So that was sort of the science and the art of it, but there is politics of it as well. Over the last few years, आपने भी news में देखा होगा कि there is a tension between US and China when it comes to technology, right? US wants to slow down the progress of Chinese economy and Chinese industry in high-tech manufacturing so that they can maintain the technological edge that they've had. And because of that, one of the areas that US government picked कि China को ये नहीं करने देना was designing chips that are very advanced processing chips. So what that did was, so अगर आप imagine करें कि दुनिया में chips बन रही थी, पहले भी बन रही थी, आज भी बन रही हैं. अगर मैं एक चिप बनाता हूँ, लेट्स से वो चिप जाती है माइक्रोवेव्स के अंदर लगती है, ठीक, माइक्रोवेव का कंट्रोल है. वो चिप 1990s में कभी डिज़ाइन हुई थी. आज उसकी जो भी नॉन रिकरेंट इंजीनियरिंग कॉस्ट थी वो बहुत अरसा हुआ पूरी हो चुकी है, क्योंकि माइक्रोवेव्स तो बहुत चेंज नहीं हुआ है 1990s से. आज भी बटन दबाते हैं, इतने मिनट ऑन कर देते हैं, वो ऑन हो जाते हैं. वो नॉन रिकरेंट इंजीनियरिंग कॉस्ट गुजर चुकी है. अब सिर्फ पर चिप अगर मुझे वो ₹2 की चिप पड़ती है तो मैं ₹4 की बेच देता हूँ, बीच में ₹2 अपना प्रॉफिट रख लेता हूँ. अल्लाह खैर सल्ला, राइट. किसी और को एक नई माइक्रोवेव की चिप बनाने की जरूरत नहीं है ना, क्योंकि वो बनाएगा, पहले अपनी इंजीनियरिंग कॉस्ट पूरी करने की कोशिश करेगा, फिर उसके बाद ₹2 की चिप बन जाएगी. वो पहले तो उसका वो जो कॉस्ट थी वो वाला खर्चा है, किसी तरह वो खर्चा बर्दाश्त कर भी ले तो फिर उसके बाद ₹2 की चिप बनाएगा, ₹4 की बेचेगा, फायदा क्या होगा? वो जो पहले ₹2 की बना रहा है ₹4 में बेच रहा है. सो देयर इज नथिंग टू डू. But because of this conflict, what the Chinese government said was, it asked its own industry कि तुम चिप बनाओ, अगर माइक्रोवेव मैन्युफैक्चरर चाइना में है तुम उस माइक्रोवेव मैन्युफैक्चरर को कहो कि मैं तुम्हें 2 रुपए की चिप बेचता हूँ। अब मसला ये है कि तुम 2 रुपए की चिप बेच नहीं सकते क्योंकि तुम्हारी एक नॉन रिकरेंट इंजीनियरिंग कॉस्ट है, ठीक? We the Chinese government will fund half of that. And when the government funds half of that, it really funds all of it, right? That's how you cook the books and you get all of the non-recurrent engineering. So, वो जो non-recurrent engineering cost है, we as the Chinese government will pay. You make this chip for 2 रुपए and make sure the microwave manufacturer uses your chip. So that we start to become self-sufficient when it comes to these chips. So, मजे की बात ये हुई कि अब इससे क्या होगा? क्या दुनिया में माइक्रोवेव की चिप्स ज़्यादा बनने लग गई? नॉट रियली। क्या माइक्रोवेव की चिप्स की प्राइस ऊपर गई या नीचे गई? प्रॉबली को थोड़ा सा फर्क पड़ा होगा, नॉट रियली। बट व्हाट इट एंडेड अप डूइंग वाज नाउ यू नीड न्यू इंजीनियर्स टू डिजाइन दैट चिप, राइट? एंड व्हाइल यू हैव इंजीनियर्स हु आर डिजाइनिंग द न्यू माइक्रोवेव चिप, तो अल्लाह का शुक्र है, अल्हम्दुलिल्लाह हम सारे भाइयों की नौकरी लग गई, राइट? बट व्हाइल यू आर डिजाइनिंग दिस न्यू चिप, यू आस्क द माइक्रोवेव मैन्युफैक्चरर, यार और क्या करें इसके अंदर? तो कहते हैं यार एक काम करो, इसके अंदर कैमरा भी लगा दो ताकि जब आलू उबल जाए ना तो माइक्रोवेव खुद ही बंद हो जाए। हम ऐसा करते हैं कि अंदर एक थर्मल सेंसर लगा देते हैं, वो हीट डिटेक्ट करेगा और सालन जब गर्म हो जाए ना तो आप बस ऑन किया करें, सालन जब गर्म हो जाएगा तो खुद ब खुद वो बंद हो जाए, आपको मिनट ना सेट करने पड़े, चाहे कभी ज़्यादा गर्म ना हो, सालन कभी ठंडा ना निकले उसमें से। कहते हैं यार गुड, तो अब तो चिप जो है वो 10 रुपए की बिकेगी। वो कहता है हाँ, अगर ये फंक्शनैलिटी डाल दो तो मैं 20 रुपए की चिप बना लूँगा। सो इट डिड 2 थिंग्स। A, it created new opportunities for electrical engineers and people who were designing chips to make more chips. And B, it accelerated the pace of innovation, right? Because now a new player is in town and they want to capture some market share. In order to capture the market share, they have to do something. See? And they were being subsidized by the government. Alhamdulillah. See? So that geopolitics created a new cycle of innovation and spurred this industry forward. So एक industry का growth rate था sort of historical rate के लोग हर कोई अमीर होता जा रहा है, वो गाड़ी खरीद रहा है, वो माइक्रोवेव खरीद रहा है, वो घर खरीद रहा है, तो therefore more and more chips are needed. Then the acceleration happened because of this, let's design more chips because we want to decouple, the two economies want to decouple from each other, which created extra sort of demand for engineers. And that's where sort of I think my personal story kind of started to converge with the larger global story. मुझे नहीं पता था ये हो रहा है, मुझे क्यों पता होगा ये हो रहा है, right? I'm just an engineer. But 2018 when I came back, so this trend was well in its way. Chinese government was doing this, and that obviously when Chinese government started to do that, US government started to invest in hardware as well. AI was coming about, people wanted new hardware to do training and to do inference of different types of AI devices. So those 3 waves kind of superimposed on each other, which made them really, really strong. And that created opportunities for us here in Pakistan to set up this industry. So if you go back to 1999, there were a couple of companies. One of them was where Abu Bakr and I worked that were designing chips in Pakistan. There were 2-3 companies that were designing chips in Pakistan. That's what inspired me कि यार ये तो मज़ेदार काम है. One of my friends, he sent me, so this is the year 1999, मैं ग्रेजुएट करने वाला हूँ, so आपके 2 साल बाद वाली कहानी जो जहाँ पे आप 2 साल बाद होंगे, राइट? पाकिस्तान इस साल की तरह वर्ल्ड कप हार चुका है, वर्ल्ड कप से बाहर हो चुका है, मैट्रिक्स नई मूवी आई है, it's all the rage, and one of my friends sends me this article that was written by Marvin Minsky. Marvin Minsky was a cognitive science professor at MIT. And his article was why humans think, machines can't. And the argument he was making is that the way we are advancing computation, a time will come when we'll be able to make machines that will be able to think better than us. And really that idea spurred कि हाँ ऐसा हो तो सकता है. And there was sort of a PhD thesis under DeHaan. He was a PhD student at MIT. The thesis was about how you can design a computer that can configure itself for the particular task you're giving it. So the hardware can change itself for the particular task. आप उसको कहें कि मैंने वीडियो प्ले करनी है तो सारा का सारा ट्रांजिस्टर्स जो है ना वो वीडियो प्लेबैक के लिए ट्यून हो जाएं, कन्फिगर हो जाएं. आप उसे कहें कि नहीं मैंने फॉर एग्जांपल फोटो एडिटिंग करनी है तो सारे के सारे चेंज हो जाएं और वो फोटो एडिटिंग के एल्गोरिथम को रन करना है. सो दैट वाज अ वेरी इंटरेस्टिंग आइडिया आउट ऑफ द सॉर्ट ऑफ बॉक्स आइडिया दैट इंस्पायर्ड मी. And And I think the conclusion I reached was that when machines get to be that smart, that they can think, I want to be around them. I want to be in that loop when we reach that point. Because I think more than just the technological advance, it will teach us about our own selves. How did we learn how to think? What is thinking? What is consciousness? हम जैसे कहते हैं कि नहीं, मशीन सोच तो सकती है पर क्रिएट तो नहीं कर सकती. What is that creativity? क्या मशीन का कोई कॉन्शियस है? क्या उसका कोई ज़मीर है? क्या उसको कोई मलामत होती है? अगर नहीं होती तो क्यों नहीं होती? वो कहाँ से, what is there that's special about us as humans, if there is anything that's special about us as humans, that will always make us different from machines? I think we're going to find the answer to that question as we get closer and closer to that point where machines can actually think and do most of the tasks that we think are cognitive tasks, right? And I think understanding machines at that level, how are they doing that? मुझे सबसे ज़्यादा interesting आजकल AI, everybody talks about AI, right? And that's probably what inspires many of you to get into computer science. What I find most interesting about AI is we've built machines and we're writing papers about, oh, I discovered कि network ये भी करता है. So हमने एक machine बना दी है, सारी की सारी हमने डिज़ाइन की है, and we are discovering its capabilities. है ना? That's amazing. And I think as we go forward, we will not be able to discover those unless we start peeling the layers of these abstractions. So abstractions are very useful in building systems. They're completely counterproductive when you're trying to understand systems. You have to start peeling those layers and start thinking across those abstractions in order to really make sense of why that's happening. See? So I think when we start building these models, people will be doing model research and people will be doing research on what happens underneath them, and people will be figuring out the mathematics of it, and people will be figuring out the electronics of it, and we'll have to think across those abstractions in order to really figure out कि ये ऐसा क्यों करती है machine and how is that different from what we do and what makes us special. So my quick journey, finished my undergraduate from Ghulam Ishaq Khan, went to do grad school, ended up working at Qualcomm for a while. During grad school, I spent a year at Microprocessors Research Lab. 2018 came back, there was no semiconductor industry in Pakistan. People used to ask me, आप पाकिस्तान जाके क्या करेंगे? मैं कहता था कुछ भी करूँगा, चिप्स तो नहीं बना रहा हूँगा क्योंकि वो तो पाकिस्तान में कोई बना नहीं रहा. But then 2019, like I said, these three waves were superimposed on each other, and that had created sort of opportunities in Pakistan. A company started here in Lahore called Lampromalin. The idea was that we were going to train people in chip design and have them work for companies that do chip design. That's what I got involved in. I started training people, so we started with a group of 25 engineers, जिनको chip design की अलिफ बे नहीं आती थी, sort of trained them into that process, then started to work with companies कि अच्छा अब हमें आ गया ये वाला काम, not the entire chip design, but sort of some piece of work within that, आप हमें ये वाला काम नहीं, ये वाला काम हम करके दिखाएंगे आपको. And we did that, and then that process continued. 2021 we started 10xEngineers with the same idea कि इसी चीज़ को आगे लेके चलते हैं, इसको accelerate करते हैं, and started doing that. At the same time, other companies were thinking of the same thing. Okay, there are very smart engineers in Pakistan, present company excluded. They're very smart engineers. I'm kidding. Obviously, present company included. There's some very smart engineers in Pakistan. They can do these hard things, and only if we have those opportunities to learn and then be able to practice that craft. Correct? So that was the idea, and a lot of companies have started. Right now, there are about 8 companies. अगर आप left side पे देखें, so these are companies that work completely in the commercial sector. So 10xEngineers, Dream, Big Semiconductors, Akal Tech. These are companies जो completely commercial काम करती हैं. Right side पे जो companies हैं, they work mostly for Pakistan's defense industry. उनके लिए systems बनाते हैं. But mashallah, there are about, as you can see on the left hand side, commercial side पे भी there are 6 to 8 companies that are working, and maybe there are a couple of logos missing क्योंकि last year की slide है. So this work is picking up. Right now there would be about 200 to 300 people who work in this industry. The brilliant thing is that the industry is growing in Pakistan, right? So imagine कि आज 200-300 लोग हैं इस industry में पाकिस्तान में. बख्तावर जैसे smart engineers who started working in this 2 years ago, right? There are like 300 of them. Let's fast forward 10 years, right? And let's imagine the future where there are 10,000 of them. that are working in this industry. At that point, where are these 200 people?
At your level.
Sorry?
At your level.
Exactly. And that's the future we want. That's the whole point. Okay, these guys will be running their own companies, building their own teams, building products, because we have to gradually get to that level of experience, expertise. They're native to this, right? They understand these domains. They're working at the cutting edge. Today, a team at 10x is working on a processor that will be the fastest processor when it comes out next year. Not the fastest processor designed by Pakistanis, but the fastest processor, period, right? The kind of stuff that Bakhtavar is doing on algorithm side. She has a patent on how to do white balance correctly. These are things that will be in phones and in technologies of the future. So 10 years from now, these people will be the anchors of this industry, and that's the future that I'm most excited about. So with that, I'll stop, and any questions, I know. मज़ा नहीं आया, आप लोगों ने सवाल नहीं किए मेरे से, सबने एक एक सवाल करना है, ठीक है? स्टार्ट करते हैं, कहाँ से स्टार्ट करते हैं? आपसे स्टार्ट करें बेटा, आपने सवाल नहीं किया, आपका नाम? समाव्या, माशाल्लाह, I've never heard that name before, very nice. समाव्या, जी, any question? कुछ भी पूछ लें.
Artificial intelligence scary or like does it excite you?
That's a very good question. Does it scare me or does it excite me? I think it excites me more than it scares me yet. I think there are scary things about it, and I don't trust a lot of people जो इस area में हैं. I think Silicon Valley culture worships just monetary success, period, which is a very bad filter to apply when you're dealing with these kind of technologies. But I think when it comes to technologies, there are probably technologies that scare me more than AI does at this point.
Robots work under us if they become more powerful than us.
Yeah, that's a good question. That is a good question. So I think we're going to learn a lot about us, right? And we're going to answer that question probably. I don't think we are there yet. कि हम अपनी cognitive understanding में वहाँ पे नहीं हैं, क्योंकि हम हमेशा ये assume करते थे कि machines ये नहीं कर सकती. So मैं आपको एक छोटी सी मजे की बात बताऊँ. So when I was an undergraduate, actually in my junior year, नहीं, sophomore year, junior year, I forget, sophomore or junior year, I really got fascinated. Actually no, it was junior year because it was I took a course in AI. My French professor थे, उन्होंने आके बड़ी AI की बातें की. तो I got really interested and I wanted to leave electrical engineering and go and learn artificial intelligence. So मैंने University of Rutgers के किसी प्रोफेसर को पता नहीं कौन था बेचारा शरीफ आदमी, उसको ईमेल की कि जी मैं बड़ा बेहतरीन बच्चा हूँ और मैं ये आपकी ट्यूटलेज में आना चाहता हूँ, तो आप मुझे ले लें. उसने मुझे अच्छी सी ईमेल का जवाब दे दिया. तो मैंने अपने सारे दोस्तों को बताया मैं जी छोड़ रहा हूँ, मैं जा रहा हूँ, मैं AI पढ़ने जा रहा हूँ. I went to my computer science dean who had a PhD in neural networks, in artificial intelligence and the type of artificial, there were two groups within artificial intelligence. Symbolic AI वाले लोग थे जो कहते थे कि knowledge को ना आप organize करेंगे, कि ये नाम हैं, ये verbs हैं, ये whatever, right? Knowledge has to be organized and then only machines can work on that knowledge. They were the dominant camp. दूसरे वो लोग थे जो न्यूरल नेटवर्क्स वाले लोग थे जो ये कहते थे कि नहीं भाई, इंसान तो ऐसे नहीं करते, इंसानों का तो बस एक दिमाग है, उसके अंदर न्यूरॉन्स हैं, न्यूरॉन्स आपस में यूँ बात करते हैं और उसी से सारा कुछ हो जाता है. हमें नहीं पता कैसे होता है बट हो जाता है. तो अगर हमने सोचना है, हमने थिंकिंग मशीन्स बनानी है, तो वी शुड जस्ट डू व्हाट द ब्रेन डज एंड फॉरगेट अबाउट ट्राइंग टू बी स्मार्ट अबाउट इट, राइट? These people are in minority. So he had a PhD in neural networks and he said to me, दिमाग खराब हो गया तुम्हारा, चुप करके बैठ जाओ, कोई नेटवर्क सेटवर्क करो, कुछ चिप्स बनाना सीखो, इसका कोई फ्यूचर नहीं है, ये बस रिसर्च का टॉपिक था, ये मर गया है. This was in the late 1990s, right? And that's how things were until about 2010. It was really in the late, early 2010s, 2012, 2013, when people started to take this stuff seriously. And part of that reason was the computation available was at a point where we could do serious things with it. So I think the idea that we're going to go from where we are today to machines that are controlling themselves and killing us all, I think there are many, many steps in between. And I fundamentally believe that human nature is good. People don't want to destroy everybody else. So I think we'll find ways to do this in a smart way. Like, at least there is distance between now and then. There's a lot of distance. Thank you. I forgot your name. समाव्या, माशाल्लाह, very nice. जी बेटा, your question.
You talked about AI performing tasks that it wasn't necessarily programmed to do.
Yes.
Like more advanced tasks like that.
Correct.
So if we're the ones that are programmed, like
Yes.
it, how
Yes.
is that even possible?
That's the amazing part of it. कि we design these machines to do a certain basic task, right? हम कहते हैं कि at a unit level, अगर आप यूँ सोचें कि we're building a system जिसका individual piece क्या कर रहा है, we determine that कि तुमने ऐसे operate करना है. But when they all start working together, they start performing tasks that we have to find out कि वो ये भी कर सकता है, ठीक? So for example, think of it this way. हमने ट्रेन किया न्यूरल नेटवर्क को यूजिंग स्टोरीज, ठीक, कि बच्चा उठा, बच्चा गया, ये हुआ, वो हुआ, ये हुआ, फलां हुआ, ढमका, राइट? अब मैं ये तो एक्सपेक्ट कर सकता हूँ कि अगर मैंने उसको कहा कि अच्छा अमजद एक बच्चा है जो कि 5वीं जमात में पढ़ता है, वो सुबह उठा तो आगे स्टोरी कंप्लीट करो, तो बेस्ड ऑन व्हाट इट नोज इट कैन से कि हाँ उसने अंडा और पराठा खाया और वो बस्ता उठाया और स्कूल चला गया या तैयार हुआ, राइट? बट इफ इट्स, अगर मैं उससे ये पूछूं कि वो कुर्सी के ऊपर बैठा या कुर्सी उसके ऊपर बैठी, what is above, what is on top and what is, that's an understanding of the physical world, right? You have to understand कि कुर्सी ज़मीन पे पड़ी होती है, correct? Now if the network is doing that, that's not something that we explicitly tried to train it to do. That's what we are discovering. Okay, these networks can have capabilities and can have understanding of things that they were not explicitly trained to do. But in some sense we should not be surprised, हमारा दिमाग भी तो ऐसे ही करता है ना, right? जी बेटा.
So I was just curious about why Intel continues to have like a monopoly over like chip design.
Oh, very good question. So Intel doesn't have a monopoly over chip design. So इस वक्त vast majority of the chips that we're using, the one in that phone and are not designed by and not actually manufactured by Intel. They're manufactured by a company in Taiwan called TSMC, Taiwan Semiconductor Manufacturing Corporation. They're manufactured by Samsung. Samsung is doing very advanced manufacturing. Intel is actually lagging behind these companies. But for a long time, Intel did have the monopoly because it was the PC era. So मजे की बात ये है कि it's related to the business side of things, ठीक? So Intel was the one that created the initial microprocessors or was the one that commercialized the microprocessors the most. तो जब तक PCs सबसे ज़्यादा dominant form of computation रहे, तो Intel के बारे नहीं आ रहे थे because they were the dominant player in that. Mobile came, and it's a very interesting dynamics. Around 2010, 2012, that's when I joined Qualcomm. मैं Intel के लोगों से बात करता तो वो कहते थे यार ये मोबाइल, इसमें क्या 2 टके का 4 आने का प्रोसेसर होता है. इसके उस वक्त जो मोबाइल फ़ोन्स थे उनके अंदर प्रोसेसर लाइक $2, $4, that was about it. हम जो प्रोसेसर बनाते हैं वो $50 से कम का तो बिकता नहीं है, और हमारे प्रोसेसर तो हज़ार डॉलर के हैं जो हम सर्वर्स में डालते हैं. It doesn't make sense for us to build these $2 chips. Let other companies build these $2 chips, right? So they were the incumbent, and they didn't realize that this is where the opportunity is going to be. PC तो कोई एक बंदा खरीदता है वो 3 साल तक चलाता है. ये मेरा ख्याल है PC जो है 5 साल पुराना होगा तो ये लगा हुआ है, right? The laptop is about 3 years old. Phone हर साल हर किसी ने $1000 का नया लेना है, right? So a lot more money started to go into mobile, and Intel just never fully realized that. And that's how they got left behind. And today they're definitely struggling. In some sense, I would say as a company they're struggling just to stay alive. We'll find out whether they do or not. इतनी बड़ी कंपनी है तो मरते मरते भी देर लगती है, लेकिन they're really struggling. Good question. Thank you. अच्छे सवाल है ना, तो सब रख के बैठे हैं अपने पास, वापस लेके जाने हैं. क्या कोई उसके ऊपर मतलब पैसे मिलते हैं सवाल वापस लेके जाएं, जमा कराएं किसी क्लास में तो. जी sure. I'll come back to you. जी.
Does one company respect the design of others, the competitors? Like
नहीं बिल्कुल आप बनाएं, मैं बनाऊं, जो मर्जी बनाएं.
Qualcomm. The Qualcomm is making chips for Intel, and it is making, designing chips for Intel, and it is designing at the same time for Samsung also.
जी.
So
Yeah, like usually not. I mean, Qualcomm sells chips to. मजे की बात ये है, take Qualcomm and Samsung, right? Samsung के फ़ोन में Qualcomm की चिप जाती है, वो चिप Qualcomm Samsung की फैक्ट्री में मैन्युफैक्चर करवाता है. सो एक तरफ Qualcomm Samsung को पैसे दे रहा है वो चिप मैन्युफैक्चर करने के, उसके बाद वही वाली चिप उठा रहा है और उसको बेच रहा है कि चल भाई तू अपने फ़ोन में डाल. सो $5 दे रहा है उसको मैन्युफैक्चर करने के और $45 की वो चिप उसको बेच रहा है. सैमसंग वो एक तरफ Qualcomm से वो चिप खरीदता है और अपने कुछ फ़ोन्स में डालता है, दूसरी तरफ उसकी एक और टीम है जो कि वही चिप बना रही है, उसी तरह की एक चिप बना रही है और कुछ फोन्स में डाल रही है, तो सैमसंग एंड क्वालकॉम आर कंपीटिंग. सो या, ऑल काइंड ऑफ रिलेशनशिप्स आर पॉसिबल. Nobody can lock, nobody wants to be locked, right? Because otherwise they will not be able to do this.
How is image signal processing different than the GPU?
The specialized functionality is different. So GPUs are meant to render images. कि मैं आपको कुछ कोड दूंगा, उस कोड की बेस पे आपने ये तस्वीर क्रिएट करनी है. The image signal processors are, this is the data coming from the sensor कि हर पिक्सल पे क्या illumination value है और उसकी बेस पे आप अच्छी सी तस्वीर बनाएं जिसमें noise ना हो and so on and so forth. Yeah, image civilization. आपका question है.
So you said when you were coming to Pakistan, तब मतलब एक semiconductors की industry
जी.
right, and then मतलब अब start हो गया.
अल्हम्दुलिल्लाह, yes.
So like पाकिस्तान के अंदर ब्रांड नहीं, लाइक कंप्यूटर मैन्युफैक्चरिंग है पाकिस्तान का, पर वो कंप्यूटर का वो ब्रांड नहीं है.
That's correct.
क्या आपको तो उसकी प्रॉस्पेक्ट्स है कि अगर कोई कंप्यूटर मैन्युफैक्चरिंग कोई बिजनेस वगैरह स्टार्ट वगैरह करे तो
अगर आप बनाएंगी तो
प्रॉस्पेक्ट्स हैं कि नहीं?
अगर आप बनाएंगे तो yeah, so that's very true. So there is one part which is manufacturing, correct? Manufacturing पाकिस्तान में नहीं होती, manufacturing पाकिस्तान में नहीं हो सकती. Probably मेरे लाइफ टाइम में तो नहीं होंगी, आप लोगों की लाइफ टाइम में शायद हो सके, लेकिन मेरी लाइफ टाइम में नहीं होंगी. Why? A, जैसे कि हमने देखा, it's extremely specialized. It costs about $10 billion to set up one factory that does the latest node manufacturing. We don't have that kind of capital. We don't have that kind of, and capital से ज़्यादा we don't have those expertise. Right? ये overnight नहीं बन जाती. It takes decades to build that level of expertise. ठीक? तो manufacturing तो नहीं हो सकती. But then again, manufacturing तो US में भी नहीं हो रही. Correct? There are many countries in the world जहाँ पे manufacturing नहीं हो रही, but they have the capability to design these things. Right? That's where, so Apple does not do manufacturing. It doesn't do manufacturing of the chip, it doesn't do manufacturing of the screen, it doesn't do manufacturing of the phone. But the $150 of parts that it pays different companies to build and manufacture, it sells the phone for $1,300, right? The value add is there. That's where the biggest value is. So our vision is to build capabilities, build expertise to design these things, because that's where the biggest value is, and that's where we don't need capital investments. We just need smart people like you. ठीक? हम ये करना शुरू कर देंगे, and inshallah in 10 years we will have companies that will be designing their entire products right out of Pakistan. It'll take time. It always takes time. Ji, your question.
More personal question,
Sure.
but how did you find your interest in electrical engineering?
Very good. I think it always starts from a good teacher, to be honest. I had a very good teacher that taught us, yani, between electrical and, so basically हुआ ये कि I was admitted to an engineering sciences program, but I had the choice to switch, right? तो उस समर में मैंने एक लॉजिक डिज़ाइन का कोर्स लिया और एक डेटा स्ट्रक्चर्स का कोर्स लिया टू डिसाइड बिटवीन इलेक्ट्रिकल इंजीनियरिंग एंड कंप्यूटर साइंस, sort of in my simplified way, right? I had a bad teacher for data structures, I had a good teacher for logic design. I thought I understood that better. It didn't make me feel stupid, right? And because it didn't, I chose that. And then, but to be honest, I think that was less important. What was important was getting inspired from good teachers to say, यार ये मज़ेदार काम है, बड़े होके ये बनना है. That's the level of expertise, that's the level of understanding I want to have, that's the level of clarity I want to have. So हमारे वो एक टीचर थे, हम ये कहते होते थे कि ये तो ऐसे है कि जैसे ट्रांजिस्टर के ना ये गेट पे खड़े हुए हैं और देख रहे हैं कि नीचे से इलेक्ट्रॉन्स कौन से किधर जा रहे हैं. You could see him visualize the complex concepts in such a clear way कि you were just like यार बस इस level of understanding पे पहुंचना है किसी भी चीज़ के बारे में. And the thing that where I thought कि I was better than average was that. So I'm a very average person, so gravitated towards things that didn't make me feel stupid. And this was one of them because of good teachers. And I think that's roughly what happens. माँ के पेट से कोई ना इलेक्ट्रिकल इंजीनियर बन के निकलता है ना मैकेनिकल इंजीनियर बन के, और ना ही कोई, मेरा ख्याल है people who sort of emphasize on मेरा aptitude जो है ना वो इसका ज़्यादा है. I don't buy that. There's no aptitude for these things. It's just that good teachers make you feel comfortable in certain domains and bad teachers don't. And as a result, you end up gravitating towards one area or the other. So yeah, I think that's what happens to everyone. We just create stories after it. Most of the people, but yeah. Question.
Sir, so building up on a previous question, and forgive me अगर ये ज़्यादा personal है, मगर आप इतना peak of innovation छोड़ के वापस पाकिस्तान?
Oh, so this is the most frequent question that I get asked. Remember, I said the second most frequent question was 10x क्या करती है? So this is the most frequent question. आप भी इसी तरफ जा रही थी, okay. So ये question हर दफा पूछा जाता है, मेरे हर interaction में पूछा जाता है. So I think इसके जवाब बहुत से different levels पे दिए जा सकते हैं. But I think at the simplest level, a lot of people who are settled or sort of working abroad do want to come back, do want to come be in the familiar areas. It's just that most people don't think they can do that. Okay, what are they going to do when they come back? And I think for whatever reason, maybe it was naivete, maybe it was intentionally closing my eyes on reality, but I thought कि नहीं मैं कुछ ना कुछ कर लूँगा, कुछ नहीं होगा, मैं पढ़ा लूँगा, मुझे पढ़ाने का शौक है, I love teaching. तो मैं था कि अच्छा मैं पढ़ा लूँगा, अच्छा पढ़ाने का भी ना हुआ तो कुछ ना कुछ तो कर लूँगा, right? I didn't know what I would do, but I had this sense that I'll do something, and so that was about it. And I think one of my very close friends asked this question, तो मैंने कहा यार बहुत complicated हो गया, दिमाग इस वक्त बड़ा घूम गया है. This was when I was coming back. इनका इसका आसान सा जवाब ये है कि I went to the US in 2000 and this was 2017 when I was thinking about coming back. तो मैंने कहा 17 साल पहले जब आया था तो उस वक्त नियत ये थी कि जाना है, पढ़ना है, सीखना है, वापस आना है. Years have passed, but the question should not be why should I go back, the question should be why should I not go back, why should I stay? And I don't have a good answer to that question. And I did not, so I thought, okay, let's give it a shot. But to be honest, it is a personal thing, and I'm temperamentally a coward in everything that I've done in my life. But I think somehow this never seemed like a brave thing to me. Absolutely not. Not a moment. I think we've been here 6 years now. 2018 के January में आए थे, तो almost 6 years. I think this was one of the best things I did in my life. Alhamdulillah. And I think a lot of it has to do with how things have panned out. Pakistan aside, right? I like not to interact with the real Pakistan. I've been so lucky that almost all of my time gets spent with young people who are positive, who are ambitious, who want to do something with their lives and lives of people around them. So मज़ा आता है. And I think, and अभी when I go back, मज़े की बात मैं आपको बताऊँ, so I go back every 3-4 months, I go to the US. Obviously business भी है और वो सब काम के लिए, right? Almost to the person, every single person that I meet, जो पाकिस्तानी social circle में या professional circle में है, they almost are always thinking कि यार you somehow are able to do something that we wish we could do. So it's the flip. यहाँ पे हर कोई होता है कि दिमाग खराब था वापस आ गए, और वहाँ पे हर किसी का होता है कि यार I wish. So it's a funny world. It's a funny world. जी okay.
I would like to know how far behind is Pakistan in this industry?
Very good question. That's a very good question. So one time we had a very senior government official visit our company, last company जिसमें मैं काम कर रहा था, और उन्होंने हमसे ये सवाल किया. So he heads arguably Pakistan's most cutting edge strategic organization, जो हमारे डिफेंस के लिए चीज़ें बनाते हैं, राइट? ये पटाखे, शुरुआती पटाखे जो बनाते हैं, राइट? उन्होंने मेरे से एग्जैक्टली ये सवाल किया कि डॉक्टर साहब बताएं हम दुनिया से कितना पीछे हैं. मैंने कहा जी इन्फिनिटी पीछे हैं. अच्छा, ऐसे जो सरकारी अफसर होते हैं उनको इस तरह का जवाब बड़ा बदतमीज़ाना सा लगता है कि यार सीधे मुँह जवाब दें आप. तो मैंने कहा जी सिंपल सी बात है, जिस दिन हम कुछ बना लेंगे ना, उस दिन मैं कहूँगा कि हमने ये जो चीज़ बनाई है, इसमें ये दुनिया ने 1980 में बनाई थी, हमने 2022 में बनाई है, तो देयरफॉर हम दुनिया से 42 साल पीछे हैं, है ना? हमने तो कुछ बनाया ही नहीं है अभी. जब हम बना लेंगे तब हम अपने आप को मेजर कर सकेंगे ना. Then we will be able to answer that question objectively, that how far behind we are from the rest of the world. So right now, the right objective answer to that question is infinity, because we haven't made anything. But I think internal capability की अगर हम बात करें, तो I think in the next 2 to 3 years, if things work out, which means that if we are able to embark on a national level project, and by national level I don't mean sarkari project, I mean where we really put together the best expertise that we have, मेरा मानना ये है, and this is what I'm actually arguing to a lot of people to give us money for, कि यार we can build something that will be around 2005 to 2010 cutting edge technology. So we will be able to say कि हाँ ये somewhere between 2005 and 2010 this was the cutting edge and we are able to build it in 2025. So I think if all goes well, then my bet will be that in 3 years we will be 15 years behind the rest of the world. This is our caveats, understand kar liye. And I think, to be honest, the biggest factor in that is not money. What is it? Yes, smart people choosing to do hard things and investing their time and energy in doing that. I think that's the biggest determinant. अगर वो होता रहा, जो कि अभी हो रहा है, smart people are doing this, smart people continue to do this, तो ये हो जाएगा. Because I think money follows wherever there's determination, there's will, there's capability, money follows that, it's not the other way around. So yeah, so inshallah, if all goes well, in 3 years, she has me on video, so if all goes well, in 3 years, we will be about 15 years behind the cutting edge in at least 1 or 2 domains, narrow domains. Yeah.
मेरा एक टेक्निकल क्वेश्चन है, क्वांटम कंप्यूटर्स में क्यूबिट्स होते हैं
जी,
और वो 4 स्टेट्स में आ सकते हैं.
Sure.
अगर सिंपल में 0 और 1 है उसमें
Yeah.
0, 1 and 2 अदर बताएंगे.
Yeah.
Zero prime
Actually,
and
4 नहीं है, but it's sort of a spectrum,
So-
phase.
अगर वोल्टेज होती है तो 1 होता है, वोल्टेज नहीं होती तो 0 होता है.
जी,
उसमें
industrial.
वो 4 स्टेट्स कैसे होता है? क्या वोल्टेज
Because there's probability, right? Okay, in some sense, you think of it this way. And by the way, actually, even sort of जिनको हम non-quantum computers ये कहते हैं, right? At a transistor level, we're dealing with quantum mechanics. The operative math is quantum mechanics at a transistor level, which is the probability. So essentially, you're figuring out that this thing is a 0 or a 1 with some probability. And that probability is a continuous function. So isliye you can have many different values. That's really what it is. So the difference really is that you can take the difference from digital computers is in digital computers we have a probability, but we map that probability to 0 or 1. हम उसे threshold कर देते हैं. हम कहते हैं अच्छा probability अगर इतनी हो गई है ना कि ये ट्रांजिस्टर ऑन है तो इसको समझो कि ये ऑन है. अगर probability इतनी हो गई है कि ये ट्रांजिस्टर ऑफ है तो समझो कि ये बिल्कुल ऑफ है, राइट? सो इफ यू इमेजिन 2x's, हम कहते हैं कि अगर 70 डिग्रीज है ना तो इसको समझ लो कि 90 डिग्रीज है, अगर 20 डिग्रीज है तो समझ लो कि 0 डिग्री है, करेक्ट? We don't deal with that in between probabilities separately. In quantum computing, you deal with those separately and you say, कि अच्छा 70% probability इसकी plus 30% probability इसकी, तो what is the answer to that computation? So you can do that computation that way.
Second question.
Sure.
जैसे TSMC वगैरह वो जब मैन्युफैक्चर करते हैं
हाँ.
वो ट्रांजिस्टर को कैसे एच करते हैं इतनी
हाँ.
जगह पे कि वो मतलब नैनोमीटर्स में सेपरेट होते हैं और सही.
Yeah. So that's a very long question to answer, right? Ultimately, it's controlling the chemistry through light and not visible light, because visible light का spectrum अगर आप देखेंगे तो हम उससे छोटे तो features बना रहे हैं, right? So how can you control something this light spectrum? So it's really controlling the chemistry through very high frequency ultraviolet lights, जिसके साथ हम उसकी chemistry करें. So हमको basically आप अगर यूँ सोचो उसका आसान kind of actually not the आसान, the actual analogy is you drop some material that blocks light, ठीक? Now when you incident this EUV on it, बाकी जगह तो expose हो गई, है ना? यहाँ पे कुछ chemical था जो कि जब लाइट उसके ऊपर पड़ती है तो जो नीचे का मटेरियल है उसके साथ रिएक्ट करके उसको डिसॉल्व कर देता है, ठीक? और यहाँ पे जो मटेरियल है वो ब्लॉक कर देता है लाइट को. तो ये वाला खड्डा बन गया इधर, है ना? जब मैंने लाइट इसके ऊपर इंसिडेंट की तो इधर एक खड्डा हो गया, ये चीज़ प्रोटेक्ट हो गई. मैंने ये खड्डा भी रिमूव कर दिया, ये भी रिमूव कर दिया, तो अब ये एक पिलर सा बन गया बीच में, है ना? सो दैट्स हाउ दिस एचिंग रियली वर्क्स. दैट्स फोटोलिथोग्राफी का फंडामेंटल प्रिंसिपल यही है. दैट्स व्हाट फोटोलिथोग्राफी इज. गुड क्वेश्चन. जी बेटा, आपका नाम? अवैस.
So what type of modules did you actually work on at Qualcomm? And are
Good
you
question.
doing anything similar at LUMS?
Sorry, are we doing similar things at 10x? So at Qualcomm, I used to work at what was called the foundation IP team. So every chip requires some basic building blocks. और वो building blocks chip के हर जगह पे इस्तेमाल होते हैं, उसके CPU में भी इस्तेमाल होते हैं, GPU पे भी इस्तेमाल होते हैं. So my team was responsible for delivering those basic building blocks, right? Simplest form उनकी जो है वो AND OR gates है. So for any process you have to have those. then you have memories that are required, then you have different types of storage elements that are required, different computation elements. So my team was responsible for delivering those basic building blocks. We did not deliver, for example, the CPU का design हम नहीं करते थे या GPU का design हम नहीं करते. There are different teams that would do. We don't do that stuff at 10x because that stuff is, for a company like Qualcomm, it makes a lot of sense to do that stuff in-house क्योंकि they do hundreds of millions of chips, right? They can do those building blocks themselves. हम जिन companies के साथ काम करते हैं, they're usually startups, they're slightly big startups or small startups, but they're usually startups. So they typically let other companies do that basic building blocks. एक तरह से वो basic building block खरीद लेते हैं और उनसे chips अपनी design करते हैं. So we don't do that stuff. At 10x, we focus on two things. One are microprocessors, specifically RISC-V based microprocessors, उनका design और उस design की verification, and the second is image processing. So those are the two areas in which we work. Microprocessors के case में we do the design, we do the verification, we do compilers for processors and all of that up and down the chain. But actually one of the LUMS graduates that we have from last year, वो compilers पे काम कर रहे हैं. तो he's a computer science graduate then. Does that answer your question? चलो, good. जी बेटा. Any one of you three जहाँ से भी शुरू कर लें. आपका नाम? Okay.
जो प्रोसेसर्स बनते हैं
जी.
जो मार्केट में अवेलेबल हैं,
हाँ.
ये ठीक है हमारे टेक्नोलॉजी की, या फिर इससे मतलब कि ज़्यादा एडवांस भी डेवलप होते हैं जो पब्लिक में अवेलेबल हैं?
किस तरह के प्रोसेसर्स की हम बात कर रहे हैं?
जैसे माइक्रो प्रोसेसर,
So your question is कि let's say you want to go and buy the latest and greatest Intel processor. Is there a processor better than that out there that's not being sold in the market? The answer is for domain specific stuff, yes, it's possible. So for example, Intel makes processors for Amazon, right? वो processor सिर्फ Amazon के AWS Amazon Web Services cloud service है, उसके servers के लिए इस्तेमाल होता है. See? So those chips are sold just to Amazon to power those. इसी तरह Intel makes stuff for, or yeah, other companies, right, make stuff for specialized needs. So yes, but in specialized domains. अगर एक desktop के processor की आप बात करें तो that's generally not the case. That's generally if a company is making it, whether it's AMD or Intel or whoever, they would put it out there. So, but domain specific stuff, yes. That Google makes transcoder chips that encode जो हम YouTube के ऊपर videos डालते हैं, right? They have to be encoded very, very quickly because there are, whatever, hundreds of thousands of hours of video being uploaded every minute. So you need a lot of specialized chips that do just that very, very efficiently. Now, there's no market for that outside of YouTube and Facebook, है ना? कहीं पे और इतनी, maybe TikTok. So maybe those three companies need ByteDance and sort of three companies need those chips. Nobody else needs that kind of chip. So उनकी market specialized है, but general purpose stuff, it's available. So for example, Qualcomm chips, you find them in phones, you can't buy individual chip. अगर आप कहेंगे यार 1 किलो देना मुझे तो वो नहीं मिलेगी, right? But if you are a phone manufacturer and you want 10 million of them, sure, Qualcomm will sell it to you, right? जी. आपका नाम बेटा? सैफुल इस्लाम. Oh, very good question. I mean, amazed nobody else asked the question कि भाई नौकरी लेनी है eventually. So what are you going to check? So we definitely want some basic understanding of the stuff that you get taught, right? So because we do most of हमारा काम जो है वो chip design से related है, so the courses that you take in undergraduates, so we actually had a whole slide on that. Logic design का आप course पढ़ेंगे, you'll study data structures and basic fundamental to programming and stuff. Then you'll take a course in computer architecture that explains कि अच्छा microprocessor क्या होता है, memory क्या होती है, वो आपस में कैसे बात करते हैं, एक program run कैसे होता है, right? Under the hood अगर आप processor को खोल के देखते और आप पढ़ते कि हो क्या रहा है तो वो कैसे काम करता है. That's what computer architecture course talks about. So we do an assessment of that. The most important ability is to be able to break down a problem. And then there is technical interviews, and most of the people, when they fail in the technical interviews, they fail at that ability. So we'll give you some problem and say, इसका कोई pseudo code या बताएं कि ये solve कैसे होगा. Come up with an algorithm to do that. What that requires is to be able to break down the problem. Right? And that's where I think the biggest fallout happens, that a lot of engineers are not able to do that. again, for specialized domains, so for example, for ISP, we would want you to have, so people who work in this area, for example, जो लोग machine learning के area में काम करें, they would have to have an understanding of how the model works. वो हाथ से बिल्कुल scratch से model लिख सकें, not just calling TensorFlow, but actually उन्हें पता हो कि एक न्यूरॉन exactly करता क्या है, कैसे करता है, sigmoid function क्या होता है, कैसे उसका कोड लिखा जाता है. So the idea is कि the fundamental stuff, and this is sort of the only recommendation I will have for you guys is कि the first 3 years of courses is where everybody is most interested in when they're hiring you. ठीक? Because these are your fundamental concept building, skill building thing that's happening. Do every single lab, make sure that you understand every single thing in these courses, right? When you get to more advanced courses, those courses are useful as a on resume building. वो जी मैंने course लिया हुआ है, whatever, I don't know, last year computer science का क्या course होगा, but say in electrical engineering they'll be like mobile communication पे मैंने course लिया हुआ है. Nobody hires you because you have taken a mobile communication course. Still you don't know anything about mobile communication after taking that course. ठीक? But people are interested, can you solve basic simple problems and do you have the ability to think through them in a systematic way, which is stuff that you will learn in your these basic courses. That so don't take them for कि अच्छा ये तो इनकी क्या फिक्र है, आखिरी साल में जाके kind of focus कर लेंगे, आखिरी साल में जाके ना दोबारा ये वाले पढ़ लेना because this is where the most interesting I think things are. So the ability we're looking for is people who can solve problems, break down more complex problems and solve them autonomously, independently. So, but typically, so because in our area, a lot of people who are coming into the company don't have the right background, so we end up hiring them as trainees and they go through an in-house training for about 6 months. We don't like that, but that's where we are today. I hope that by the time you guys will graduate, the need for that training will reduce. There will be enough people who will be coming with the right academic background that we will not have to do 6 months of training. We'll probably do like a couple of months and then people will be able to start working. But जब तक वो नहीं होता, so we have this about 6 to 8 months of internal training program. Once people finish that training, then they start working on either internal projects, or client projects, or something like that. Good, Ji. See, they were all great questions that you had, but you were trying to get refunds on those questions. Now you can't get refunds on those questions, but we had fun.